again, in this lesson we're going to be looking at area on the coordinate plane, sometimes referred to as coordinate geometry. We're simply graphing shapes and using the coordinate plane to figure out how long they are, what the dimensions are, so forth. Okay, so let's go ahead and try number 2 here. We have a triangle. We need to find its base and its height. Now neither are labeled, so I need a side that I can count the distance of. These diagonal sides here and here, I can't measure those lengths without doing some math that's above our grade level right now. So we're not going to use that side. We're going to use this side here. So we want to figure out how long that side is. Well, we can simply, count over how many steps it is from side to side. You can also use the fact that it's starting at -6 and going all the way up to +5. So that would conclude that that is 11 units. Now, we need to figure out the height. The height is going to be perpendicular to the furthest distance of the triangle. So we're going to need to make that right here. So it's going to basically go through the other point of our triangle here. So trying to draw a straight line here. So that distance there is our height. So again, that's going from -4 up to +4. That is a distance of 8 units. There weren't centimeters or inches marked, so we're just going to call them units. So it's 11 units base, 8 units height. We are able to just count that on the coordinate plane. So we're going to use our formula for the area of a triangle, 1/2 base times the height. So area is equal to 1/2 11 times 8, and that's going to give us 44. We'll call that units squared. Again, we don't have a specific unit. We're just going to call them units squared. Great. Let's just try a few more on the coordinate plane. Okay, here we have a trapezoid. So again, for a trapezoid, you need to identify what are the bases and what's the height. So base here, because these two sides are parallel to each other, and then we're going to need some distance that's perpendicular to both the bases there. So the top base here goes from -3 to +2, so that's a length of 5. The other base here goes from -5 to +5, so that's 10, and the height here goes from -1 to 6, so that is a height of 5 that way. Okay, so now we have all the information we need to use our trapezoid formula, 1/2 height times base 1 plus base 2. We'll plug in the numbers we have. That's 1/2 times 5 times the sum of 5 plus 10. So that's going to give us a total of 37.5 units squared. Okay, we're going to skip the example here, which is a square. We're going to look at some more examples that might be a little bit trickier here. All right, don't be confused. This is a trapezoid. It's just sideways. All right, let's look at one where we have to graph the points ourselves. All right, so -7, 7. That's going to be -7, and that's going to be +7 on the y-axis. So that's A, and we'll label it. B is -7, -7, way down here. And C is +7, -7 over here. Okay, so we'll go ahead and try to draw the shape that connects all of these together. Alright, doing my best to connect that. Of course, we have 3 points. You should have guessed we're going to get a triangle. Okay, so this is actually a right triangle. We have these two sides are perpendicular to each other. So in this instance, this side, which is 14 from -7 to +7, and this side, which is from -7 to +7, also 14, those are the base and the height. So they happen to be lengths of the triangle in this instance. So again, 1/2 base times height. So 1/2 times 14 times 14, which will be 98 units squared. Okay, I want to look at number 12, because in number 12 something a little bit different happens. We've seen it off of the coordinate plane, but we want to make sure we can identify it here as well. So here we have a graph for us, and this is the only side of the triangle that we can easily measure the length of, because it's straight vertical or straight horizontal. So the distance of that is from 1 to -5, so that's a distance of 5 units. Now, if we're trying to measure the height, we really can't go through the middle of the triangle, because that's not going to get to the highest point here. So you've seen this in the diagrams. We're going to kind of extend the triangle out this way, so we can see it's the distance here that it is. It's going from -3 all the way up to 6, so that means that this must be 9 units that way. So that's going to be our height. It's got to be perpendicular to the base. So area equals 1/2 base times height, so area equals 1/2 5 times 9, and we're going to get 22.5 units squared for area. So watch out when sometimes the base is outside of, the height is outside of the triangle, but otherwise you should be good to go. We'll practice the odd ones for homework.